angles and circle, sorry. Well, in fact, there's angles and circles because we are dealing with angles, circles, and this kind of stuff. So the first thing that we try to define is tangential angle. What kind of angles are tangential? Well, if a tangent, remember in section 6.1, if you forgot it, just go back to the first video and you can see what was tangent. If a tangent and a chord intersect each other on a circle, look, the tangent is here. It is a line segment that will intersect the circle at one point. So here is the tangent, that's ABC. So BC is the tangent and AB is the chord. When these two intersect each other on the circle, they will form an angle which we call it tangential angle. At point of tangency, by the way, that is the point of tangency, when they intersect each other, they will form an angle that we call it tangential angle, which is angle D. And the measure of that angle, the measure of tangential angle always is equal to half of this arc that across from it, which means the arc AB divided by 2 is equal to the measure of our tangential angle. Here we have got two awesome examples. Well, the first one, as you can see here, is that line is our tangent, and here is one chord of the circle, and they intersect each other at this point on the circle. Then they form a tangential angle. Right now, we said that tangential angle is exactly half of the arc across from it. Well, the measure of that arc is 110 degrees. Half of it is equal to 55. So find the value of x, angle x. You can see that angle x is the measure of angle x is equal to half of the arc across from it. Well, it's equal to 55 degrees. Second example. Well, it gave us the tangential angle. As you can see here is the tangent, and that is one chord of the circle that they intersect each other at this point on the circle. At points of tangency, you can see that. Well, the tangential angle is equal to 110. We know that the tangential angle is half of this arc across from it, which means that arc divided by 2 is equal to 110. So what should be the measure of this arc? It should be 220. In order to, if we divide it by 2, we get 110, which is the measure of that tangential angle. That is why the measure of that arc, which is arc MN, the arc MN is going to be 220 degrees. So basically, tangential angle is half of the arc across from it. That's all about tangential angle. Well, the next matter that we should know about it, and it is very important, and we need to focus on it because probably one question from this section will come, and it might be from this theorem, which is interior chords theorem, where we have two chords inside the circle and they intersect each other, okay? But they should be inside the angle. Since we are saying that interior, so interior means they should be inside the circle. Then we are going to have a formula, okay? Then the measure of this interior angle, or that one, is going to be something like that. We will say that the measure of this arc and that arc, we are going to add them and divide it by 2, then you will get the measure of our interior angle. So again, go back to the title, interior chords theorem. When we have two chords, two interior chords that they intersect each other, well, the measure of interior angle, for instance, that angle which is angle x, it's a kind of interior angle. The measure of that interior angle is the sum, or you can say the addition of intersected arcs. Okay? the arc AB plus the arc BC divided by 2, it will give us the measure of x, which is our interior angle. Well, here we have got two examples that we can definitely get the idea from these two examples. So what kind of color? I think that one is better. Well, here we have got a circle, and fine. So here we have a circle, and inside our circle we have two chords that they intersect each other. Then they will form the interior angles. Alright? So here our interior angles is M. And the question asks, find the value of angle M. So according to interior chords theorem, the measure of M is equal to the addition of the intercepted arcs, which is here. That arc is 100 plus that one is 32. And we said divided by 2. So again, I'm going to repeat it. If we have two interior chords that they intersect each other, then they will form interior angle. And the measure of that interior angle is equal to the sum of intercepted arcs divided by 2. So 100 plus 32 is equal to 132, and divided by 2, it is equal to 66. That is the measure of angle M, which is our interior angle. Here we have got one more example. Sorry, guys. In this example, again, we have got a circle and two chords that they intersect each other. And again, they form a kind of interior angle. Then, the question called that interior angle X. Then we said that it is equal to the sum of intercepted arcs. Alright, so right now that one is 33, and here we have got 13. The sum of them means we need to add them and divide it by 2. So 33 plus 30, it is going to be 46 divided by 2. Then 46 divided by 2 will give us the measure of our interior angle. Then 46 divided by 3 is equal to 23. So the measure of x is equal to 23 degrees. So in interior angles, whenever we have interior chords that they intersect each other, they will form interior angles, and the measure of the interior angle is equal to sum of the intersected arcs divided by 2, or half of the intersected arcs. Next, we have got exterior angles theorem. Okay, so we had tangential in this section. Then we came up with interior angles, interior chords, and here we have got exterior angle theorem, or we can say exterior chords theorem. Well, exterior chords theorem said that, look guys, we have got two chords of this circle that they intersect each other outside of the circle. That's why we call them exterior. Okay, they are out of the circle, the point of intersection. Alright, look, as you can see, the point of intersection here is A, and it is out of the circle. Here we have got three different cases. For that one, again, we have two tangents. That is also kind of exterior chords theorem. They intersect each other out of the circle, and here one tangent and one chord, they intersect each other outside of the circle. In all of them we have got the same formula, and the formula is the only difference between interior and exterior is that sign between them. For the interior, we just add the intersected arcs, but here in exterior we will subtract the intersected arcs. The smaller one subtracted from the bigger one. Here, for example, look at the blue figures, the blue figure. Well, these two chords intersect each other at this point, which is point A. So they form two arcs, arc BC and arc BC. Then we will see that the measure of that angle is this exterior angle, is equal to the bigger arc, which is arc BC, minus the measure of the smaller arc, which is BE, and always divided by 2. Remember, in interior angle, in interior chords theorem, we divided by 2. In exterior, we also are going to divide it by 2. But remember, in interior, we will add, but in exterior, we will subtract. Alright, so we have 3 different examples here, and I hope that you listen to me in order to catch every single point from this matter. So the first one, as you can see, we have got 2 chords, and they intersect each other where? Outside of the circle. So we are dealing with exterior chords theorem. We said the measure of our exterior angle is going to be the bigger arc here, as you can visualize, is equal to 75 minus the smaller one, which is 45 divided by 2. Then it is equal to 75 minus 45. I'm pretty sure that you know that it's equal to 30. Divided by 2, it is equal to 15. So it means that our exterior angle's measure is equal to 15 degrees. The second example says, the second case, we have got 2 tangents. Still, we are going to use the same formula, which means that, well, here the exterior angle's name is y, and it is equal to the bigger arc, which is 200, minus the smaller one, 550, divided by 2. Guys, don't forget to divide by 2, please. So 200 minus 50, it is equal to 150. Divided by 2, so the measure of our exterior angle is equal to 75 degrees. I hope that you follow me, guys, because these are really important, and there will be at least one question from this section in Nishtimany, according to that experience that I have, and according to what I've seen in Nishtimany examination. Well, the third case, we have got 1 tangent and 1 chord, that they intersect each other outside of the circle. So the name of our exterior angle is equal to is Z. So the measure of Z is equal to the bigger arc, which is 100, the measure of that 100, minus the smaller one, which is 30, divided by 2. Then 100 minus 30, it is equal to 70. Divided by 2, the result is going to be 35 degrees. And all the examples regarding the exterior chords theorem are going to be solved by this formula. The subtraction of the difference of the arcs that across from the 2 intersected arcs. Chord sign. Well, the lesson was about these 3 layers, which is tangential angle that was equal to half of the arc across from it. Interior chords theorem, that was the addition of these 2 arcs that across from it divided by 2, and the exterior angle was the subtraction of arcs across from it and then divided by 2. And yet there is an amazing example that I just want to solve it with you guys. I don't want to make the video long because I know that you might get bored with the video, but I hope that you follow me until now. Define the question for the Nishtimany. So imagine right now it's the day of the math Nishtimany examination, and you are looking at this question. The question asks you to find the value of angle x. So if you can see it, angle x is a kind of exterior angle. It's outside of the circle. So here, that arc is equal to 104. And as you can see, the circle here is, the center of the circle is here, and that chord across goes from the center. So it means that arc is a semicircle. What is the measure of a semicircle? Arc 180 degrees. And that arc, that small one, is 20. So we are going to add these 3 and plus to that part and then equal to full arc. What is the measure of the full arc? 360. Okay, so 104 plus 20, 124. Plus 118, it is equal to 304. Then if you subtract this 304 from 360, whatever will remain is going to be for this part. So what is the result of 360 minus 304? It is equal to 56. So it means that the measure of that arc is equal to 56. Now easily we can find the x by the theorem of exterior cos theorem. So it says that if we have exterior angle, so it is equal to the bigger one, the bigger arc, that's the cos moment is equal to 56 minus, remember exterior was minus the smaller one, which is 20, and then divided by. So 56 minus 20 is equal to 36. Divided by 2, and 2 degrees. So the result of our calculation is equal to 80 degrees, which means that the measure of our exterior angle is equal to 80 degrees. Thank you so much for listening to me, and I hope that you will